Let us do another problem related to the potentiometer. So we have a circuit, primary cell is there, and another cell whose EMF is given as 1.5, and when it is in open circuit means when the galvanometer is showing zero deflection and the cell, there is no resistance across the cell, then the balancing length is 76.3 centimeter, or in other words the EMF of the cell is balanced. So we already know EMF is equal to potential gradient multiplied by the balancing length. So potential gradient multiplied by balancing length is 76.3 centimeter, and the EMF is already given 1.5 volt. Now when closed circuited means you are connecting a resistance across the unknown cell. Not unknown cell, already in this case the value is given, but what we normally choose as the unknown cell. So here that is 9.5 volt. So it means some current is also flowing through this 9.5 volt. So then it becomes a closed circuit. So in that case the potential difference which is being balanced, we will denote by the letter V and not by E. So for V, the balancing length is 64.8 centimeter, and you are supposed to find what is the internal resistance of this cell. So when the cell is in open circuit means there is no resistance connected across this, the balancing length is 76.3. when you connect a resistance of 9.5 ohms across it, and when the current flows through both the resistor, then the balancing length falls to 64.8 centimeter. They are asking you to find the internal resistance of the cell. Now internal resistance of the cell is given by the equation R equals capital R times E by V minus 1. Now capital R is the resistance which you connect across the cell to make it closed circuit. So in this case that is 9.5 ohms, and E is the EMF of the cell when it is in open circuit. So that is 1.5, and you have to find this V to find the unknown resistance. How to find this V? See, as per the potentiometer logic, EMF is equal to potential gradient multiplied by the balancing length. So in first case EMF is 1.5 volt, potential gradient is not known, multiplied by balancing length is 76.3. In the second case V is not known for us, unknown voltage, let it be this V when it is closed circuit. So V equal to again potential gradient multiplied by the balancing length, that is 64.8. So when you divide these two equations, so you have 1.5 divided by the V equals 76.3 divided by 64.8, or you will get V equals 1.5 multiplied by 64.8 divided by 76.3. So it will be equal to 1.5 multiplied by 64.8 divided by 76.3 is equal to 1.27 volt. So from this you can find out the value of V, and once you substitute, you will get the unknown resistance equals 9.5 multiplied by 1.5 divided by 1.27 minus 1. So R will be equal to 1.5 divided by 1.27 minus 1 multiplied by 9.5 which will be equal to 1.72 ohms. So this is the internal resistance of the cell. So the question is something like this. They have directly given the EMF of the cell, and they are saying when it is in open circuit, it balances at a particular length. When you connect a resistance across it and you allow you convert it into a closed circuit, then the balancing index differs, falls to 64.8. Find the unknown resistance. So you have to remember this formula: R equals capital R E by V minus 1. This capital R is the resistance which you connect across the cell to make it closed circuit. E is the EMF of the cell when the circuit was in open, means no resistance was across it, and V is the potential difference or the balance. Once you make it as closed circuit, then the E becomes V. So that V you have to find. How to find that V? Using the potentiometer logic. EMF is equal to potential gradient multiplied by the balancing length, and you will get two equations, one with E and one with the V. You divide both equations, from that you can find V and substitute in this relation.